Hello there. We are going to jump back to section 5.3 because we have some functions that we need to graph. So we're going to be graphing these radical functions. And hopefully from your reading, you know that we are going to be adding some parent functions to our list of functions. And that was going to be our square root and our cube root. We're going to start with our square root, and just an FYI, I'm going to write on the left side of the paper, and I'm going to save the right side of the paper for our cube root. So if you are writing your notes, just an FYI on what I'm doing here, in case you maybe want to fold your paper in half or something like that. So of course the square root function is f of x is equal to the square root of x. So let's set up a set of axes here. And as we graph this, I like to, of course, look at a x and y table just to kind of get us an idea as to what points we are plotting. So if we are going to go ahead and start with 0, well, the square root of 0 is equal to 0, so we can plot that right at the origin. That's our starting point. And plugging in 1, the square root of 1 is 1, so we go over 1, up 1, next point that we have. And then we start getting into some irrational numbers, right? The square root of 2 is about 1.4. It's really hard to graph the square root of 2. So we're going to start looking at inputs that we know we can take the square root of. For example, we know we can take the square root of 4, and that's going to give us an output of 2. We know we can take the square root of 9, 5, 6, 7, 8, 9. That's going to give us an output of 3. And as you can see here, this is kind of a curved graph here. It kind of looks like half of a parabola on its side. That's what we want to think about in here. And of course, if we were to go ahead and put in a negative number, for example, -1, we would come up with an undefined answer. We can't graph that because that is I. So just some notes here. We know that the domain of this function is from 0 to infinity, aka for the domain of this function we can only have inputs from 0 higher, and the range is also from 0 to infinity. We're only going to have outputs that are higher than that are 0 or higher. Sorry, that infinity was not very pretty. There we go. Okay, so the cool thing about these, once you have your parent functions, of course, is that you graph them using our transformations. So we graph, knowing those rules that we have about left and right, inside the parentheses, outside, graph using our transformations. So for example 1 here, we're going to have f of x is equal to the square root of x minus 3 minus 2. So this function right here, x minus 3, that's inside the parentheses. And we know that it's opposite, right? X minus h. So this is going to be a function of right 3. And then this is outside, right? That 2 is outside, so this is now going to be down 2 units. All right, so let's go ahead and take a peek at a set of axes here. Move this up a little bit so that we can move that function down. All right, so I'm going to start with our transformation. So from our origin right here, I'm going to go ahead, I'm going to go right 3 and down 2. I'm going to put a point right here. And then from that point, I use our relationship of our function. So we're going to go over 1, up 1, again, over 1, up 1, plot a point, because there's no stretch on this. The stretch is just 1. Over 4, up 2. If you'll notice, it's the same type of relationship as a parabola, right? Except switched up. It's what we're going to call an inverse. And of course, over 9, up 3. I'm not sure, I can't go over 9 here. I ran out of a set of axes. But from here, I can go ahead and make that nice curve. and graph my function. So going ahead and knowing all of these kind of relationships here, so over 1 up 1, over 4 up 2, over 9 up 3, and of course over 16 up 4, that you'd be able to do there. That's as easy as that. We're just going to use our transformations to go ahead and graph these. I'm going to make this a little bit shorter here. There we go. Nope, there. Perfect. All right, so let's take a peek at another example. Example 2 is now going to be a reflection because we're going to have f of x is equal to negative square root of x plus 1 plus 3. So let's talk about these transformations. Of course, this is the reflection. There we go. Reflection over, this is outside the parentheses, so it's over the x-axis. It's going to flip it down. Just like what your parabola did, right? Your parabola flipped down. Now, this is now going to go left 1, and this is going to go up 3. So let's go ahead and set up a set of axes here. And right here. That looks pretty good. Go back to pink. So let's first start with the left 1 and up 3. So from our origin here, we're going to go left 1 and then up 3. 1, 2, 3. So right here is where I'm going to start my graph. There's my starting point. Okay, now I'm going to have to, normally on this one we go over 1, up 1, but I now need to reflect it over the x-axis. So I need to go over 1, down 1, over 4, down 2, over 9, if I can fit it in here, 1, 2, 3, 4, 5, 6, 7, 8, 9, down 3. And then from here, go ahead and make your nice curve. Oopsies, sorry. I know they're a little tricky. Sometimes you kind of need to turn your paper sometimes to get that nice curve. And sorry, mine's not the best. But because I have my points plotted, you know that they're going through there. And as always, it's a really good idea to check your work here. So just mentally, I'm going to go ahead, I'm going to check an input of, this is 8, right? 1, 2, 3, 4, 5, 6, 7, 8. So plugging in 8 here, we have 8 plus 1, that's 9. Square root of 9 is 3. Negative 3 plus 3, that gives me an output of 0. I know I plotted the correct point. So we're going to keep going with these transformations here. I've already used that color. Let's go to our second page. We'll go here, red. I want to start looking a little bit about a different reflection. So we're going to do f of x, I'm on example 3. F of x is equal to the square root of negative x minus 2. Now, we haven't really looked at this reflection before, but because it's inside the parentheses, it's actually a reflection over the y-axis. And we haven't worried about it before because a parabola, or all the functions that we have looked at, have been, it doesn't really matter if they were over the y-axis because it just looked like a mirror, right? A parabola had the same going on the left that it had going on the right. But with a radical now, it doesn't look the same on the right as it does on the left. So we're going to go ahead, we're going to reflect this over the y-axis. First thing is that this is a shift down 2. I'm going to start there, so I'm going to start my graph right here. Now usually we would go over 1, up 1, but now I need to flip it over here to the y, or flip it over the y-axis. So I'm actually going to go to the left 1, up 1. And then, once again, that same relationship, I'm going to go to the left 4, up 2. That's all I can fit in here. I can't go over 9. So I'm just going to go ahead and draw the best curve that I can. Put put an arrow on there that it's going on. And as always, a really good idea to go ahead and check some points here. So I'm going to check this output of 4, or sorry, negative 4. Negative 4 is a positive 4. Square root of positive 4 is 2. 2 minus 2 is 0. That gets me an output of 0. I'm on the right track. Okay. So the thing about these, of course, is that we can also stretch them. And the stretching works exactly the same, but you have to be, of course, a little bit careful on your outputs on this one. So x minus 2. Okay, so we now know this is a stretch of 3. And that this is a horizontal transformation, so this is now going to go right 2. All right, so looking at our set of axes, I know that we're going to go right 2, so I want to kind of set my axes up over on the left side so I have plenty of room to work. All right, going ahead, starting at my point, I'm going to do my transformation, so right 2. So I'm going to plot my starting point right here. All right, now we're going to go ahead and we are going to stretch it by 3. So normally I would go over 1, up 1, and I would plot my point right here. But we need to stretch our output by 3. So now I'm going to go over 1, up 3, and that's my new output. Just like we did with our parabolas and any of our other functions, we stretched them out. So normally from this point I'd go over 4, 1, 2, 3, 4, and up. Ooh, I ran out of room a little bit. And we go ahead and go up 2. I'm going to stretch that by 3. So 2 times 3 is 6. So 1, 2, 3, 4, 5, 6 right here. And we're going to draw that curve. I'm going to run into my room right there, but hopefully you left enough room on that paper to go ahead and write it out there. Okay, so one more radical or square root function for you. Example 5, and this is something really important, so go ahead and lock in on this one. I'm going to put a stretch on it, but I'm also going to put a reflection on the inside of the radical sign and a horizontal transformation. So at this point, you would look at this and go, well, x plus 1, that of course means I'm going to go ahead and move it to the left one, but be careful about this negative sign here. So how we would actually write this function is that we would factor out the reflection, and now we see a horizontal transformation of to the right one. So this now became a horizontal transformation of to the right one. So be very careful on that when you have a negative inside your parentheses. So now we can go ahead and graph this guy. Oops, draw a set of axes. Hopefully I have enough room here. There we go. Okay, so we're going to go to the right one. I'm going to start it right here, but also I need to think about the other things I've got going on. So this guy tells me that I need to go ahead and need to reflect it over the y-axis, so it needs to be going this way. It needs to be going to the left. And I need to stretch it by a factor of 2. So let's go ahead, we would raise it, go up, we go over 1, up 1, so we're now going to go over 1, up 2. And plot a point here. And now we're going to usually go over 4, up 2, but we're now going to go over 4, up 4, stretch that output by 2. And as always, it's a really good idea to check your values. So quickly, I'm just going to go ahead. I'm going to plug in 1 here to make sure I know what's going on. So we have negative 1 plus 1, that's 0. Square root of 0 is 0, times 2 is 0. I'm also going to input 0 here. So negative 0 is just 0. 0 plus 1 is 1. Square root of 1 is 1 times 2. That gives me an output of 2. So all my inputs and outputs are working out there. All right, so those are our radical and our square root functions. But we also need to look, of course, at our cube root function. So let's head back up to the top. Our parent function now is also going to be a cube root. And once again, please add these to your, I'll make this G, to your parent functions, the cube root of x. And on our cube root of x, it's a good idea, of course, to make a table of values. I'm going to put it up. I'll put it right over here on the side. So we have x and y for our cube root. And we'll also draw a set of axes. I'm definitely going to run out of room if I do it there. So I need to move this guy over. And put this all the way around over. Man, sorry guys. I apologize. It's taking me a while to set up my axes. Here we go. All right, now we have our cube root. So let's start plugging in some values. 0, the cube root of 0 is 0. We're going to start right here at the origin, like most of our parent functions. Then we have 1. The cube root of 1 is 1, so we're going to go over 1, up 1. Cube root of 2, that's not a rational number, it's about 1.2. So let's talk about numbers that we can take cube roots of. That would be 8. Cube root of 8 is 2. So you go over 8, right? So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, and then up 2. All right, and then here's the thing is that you can actually plug negative numbers into cube root. So you can take, hey, -1, then cube root of -1 is -1. Cube root of -8 is -2. 1, 2, 3, 4, 5, 6, 7, 8, all the way over here. And now you can see that this parent function kind of looks like an S shaped here. Like a really stretched out S on that one. I could have done a little better job of drawing those curves in there. But that's your cube root parent function. And just like with your radical functions, you're going to go ahead and graph using our transformations. I was on example 5, so I'm on example 6. So we're going to say g of x is equal to the cube root of x minus 2 plus 1. So just kind of reviewing there, this of course is inside, so this means we're going to go to the right 2, and this is also going to be up 1. So drawing our set of axes here, and it's kind of a good idea to think about your transformations and where this function's going, so you can set your origin where you need to. We're going to move from our origin. So looking at our parent function here, we're going to use this origin and we're going to move it using our transformation. So we're going to start with to the right 2, up 1. And this is where I'm going to start this graph. So that's my starting point to kind of give you an idea as to where this is at. This matches up with this part of your function. So now from here we go over 1, up 1. So the same thing here, over 1, up 1, because we don't have any sort of stretch. And you go down 1, over 1, over 1. The next thing is that you're going to go over 8. So 1, 2, 3, 4, 5, 6, 7, 8, up 2. And over 8, 1, 2, 3, 4, 5, 6, 7, 8, down 2. As always, a good idea to go ahead and plug in some values, and you just kind of draw it making these curves. Oops, wrong way with that curve. There we go. Makes it kind of an S shape on this. And of course draw your arrows on the sides to make sure that it goes in both directions. I'm actually going to erase this guy right here because that looks bad. Let's try this one more time. I find it sometimes easier to go kind of from the origin of your graph and take it out that way. That way you can get these curves. All right, so now let's look a little bit at a reflection on this. So example 7, and I only have, I think, a few of these for you to work with your cube roots. G of x is equal to the negative cube root of x plus 3. So when we have this, it's now going to be reflected over the x-axis. And the thing about your cube roots is that your reflections start to kind of look the same. You just have to be careful which way they're going. So kind of like your parabolas on that one. So I'm going to start by graphing the start of this. So this is going up 3. So it's going to go up 3. So 1, 2, 3. We're going to start here. And then we're going to go ahead and we're going to flip it down. So I'm going to go over 1, down 1. And then I'm also going to go over 8. So 1, 2, 3, 4, 5, 6. Oops. 1, 2, 3, 4, 5, 6, 7, 8. Down 2. Now I'm going to go to the left one, now up 1. And I don't really have room to go over there to the 8, but we can go ahead and see that this is curving through as best as you can on that one. All right, last example for you, I promise. These are kind of our longest notes that we've had in a while. So example 8, and that's because graphing always does kind of take a little bit of time here. Example 8 is going to go ahead and be g of x is equal to 2 times the cube root of x plus 2. All right, so this has a stretch of 2, and it's moving up 2 units. So let's start by drawing our axes. And I'm going to shift this down a little bit because I know that we're going to be moving it up 2 anyways. All right, so start by drawing your origin here. And thinking about that stretch, we normally go over 1, up 1 for our cube root. We're now going to go over 1, up 2. Go ahead, plot your point. We normally go over 8, 1, 2, 3, 4, 5, 6, 7, 8, and then we go up 2. We're now going to go up 4. So 1, 2, 3, 4, 5, 6. Oops, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Then same thing on the other direction. We normally go over 1, down 1. We're going to go over 1, down 2. 6, 7, 8, 1, 2, 3, 4, and over 8, down 4. And now you can see that this graph is all stretched out. I'm doing the best that I can with those curves right now. I understand that they are challenging to get. I'm going to go back and erase this. And that's the best that we got for that guy on your graphs. So we'll practice this tomorrow. Hopefully you got a little bit better idea of your parent graphs and your transformations. As a reminder, you need to add these parent functions to your parent function page.